Thank you. Great to be back. Okay, so we are going to now dive into our coding portion of the case. And this is really the fun part. This is where you actually get to see the code and get to play with stuff and explore. Now, with that being said, I heard through the grapevine that y'all will actually have a more in-depth coding session tomorrow, I believe. So for this case, we're going to go through all of the coding sessions, but we're really just going to talk about the code at more of a high level. And we're not going to spend too much time on the actual coding exercises to give you the ability to work through those in this more in-depth session that y'all are having. So with that, we're going to dive into this. We're going to learn a lot of new coding concepts, hopefully. And this really is a pretty in-depth exploratory analysis. Well, exploratory data cleaning, not really a full data analysis. But this really covers a lot of bases about how we might want to go through and modify or prepare our data in a real world setting. So first, we're dealing with our unclean data regarding our bike share analytics platform. One set of tools that we will be using is a .groupby function. Our group by function is used to group our data based on one of our categories and to then perform functions on those groups of data. Right? So a function that we can use to work through all these different groups is .count, which counts the number of rows associated within each group. Now, .count is a much broader function that just counts whatever it's sort of passed, but it's often used in the group by or in combination with group by to determine the size of groups within our data set. Cool. Now, it can also be a good habit when we first get data just to open it up and get a feel for it by manually going through maybe a couple thousand lines of rows. Now, 1,000 lines of rows sounds like a lot of data, but you're really just skimming over it and looking for obvious things that stick out to you that you know you're going to need to change. And this is a skill that you build over time, right? So the more experience you have with data and the more diverse your data sets are that you work with. Let me just zoom in here for y'all really quickly. I'm sorry, I saw that. Okay. But when you start to work with different data sets, you'll build up that skill set and you'll be able to identify things more quickly. So that's something that you really have to just give yourself time with. One of the first things that we're going to do here is read in our data, specifically our trips data, using the .read_CSV function. This is a pretty standard function in pandas, and I'm pretty sure y'all have already seen this before. But if not, this is a function that allows us to read in a CSV file. Now, there are a bunch of options that are related with this, but the default functionality of read CSV is operationalized to read in comma separated value data files, where the first row in our data set is the heading and all of our values are within the file separated by commas. You can actually change the separator in this function to be a decimal or a colon or a tab even. But since a CSV is standardized with a comma, this function is standardized with a comma. Okay. So first things first, we have some import functions here. We're bringing in NumPy and pandas. Pandas is for our data frames. NumPy is for series. You can think of a series as a singular column within a data frame. We're bringing in import math. This is going to be used to do some math stuff later on. It's a pretty base package. And we're also importing base 64. Now, this is a package that we use to get access to operations within our actual machine. It's a way to get to our base operating system. And there's a bunch of functions in here. It's a pretty expansive package, but we're only going to be using a couple in here. Now we're bringing in our data using our PD for pandas.read CSV function. We're bringing in our file name. And now you may have noticed that our number of rows here is set to 10,000. Now, the reason why we're doing that is because we just want a sample of our data set for this cleaning and these analyses. Our overall data set is over 3 million rows, which is a lot of data for the sort of explanatory introductory purposes of this case. But if we were doing this in a practical setting, we would probably want to clean and modify and prepare our entire data science package, or our entire data set, sorry. Okay. Cool. And then here we have df.head. Head gives us the first 5 rows within our data set and is built into pandas. And here we are just calling it to get a quick preview of the top of our data set. Now, I see a couple questions in here, so I can answer some of these. Why do we see NumPy and Pandas imports together? Pandas is actually built on top of NumPy, but NumPy is specialized for series operations. So if we are doing operations that only deal with one column at a time, which we will be doing later on in this case, we would want to use NumPy because it has those specialized functions. So they often are loaded in together and operated with each other. It's really just good practice to import them both together. So that's good. If a CSV is separated by values other than commas, you just work with whatever value is the separator. You may see semicolons as a separator. You would just label that as the separator in the function. And it is as simple as just expanding this, adding in sep equals and whatever the separator is. So that is a way to modify that function to work with other separator values instead of commas. Okay, cool. So let's continue through here. So as we discussed before, the first step that we ought to take with any new data set is to familiarize yourself with it. And now the manual brute force approach is really just opening it up and looking at a couple of data set or a couple of a bunch of rows within the data set. But for example, like this is a 3 million row data set. You probably wouldn't want to just open that up. You would probably want to be more strategic in how you're looking at it. So using .head is one way to do that. And .head, you can actually customize this by adding in a value to get more or less rows if you'd like. So we could get 10 rows if we wanted to instead of 5. We could even get 100 if we wanted to. But really, we're just using it to get a feel of our data set. So we can also pull up the column names of each of the columns in our data set. And here we use this dot columns. Now this dot columns is not actually a function in and of itself, where like dot head is. It's sort of an attribute of the data frame. So when we run this, we are really just calling this attribute of the data frame to get info about our data frame. So when we run this, we can see that we have rental ID, duration, bike ID, end date, end station ID, so on and so forth. So the features or the columns that we have within our data set include our rental ID, which is the sort of identification of the rental of whatever rental occurrence is happening. We have the duration or the duration of the journey in seconds, the bike ID, the end date of the journey, the end station ID, the start date, the start station ID. We have our tags, which we looked at previously as low, medium, and high, and we know that there are more in there than just that. And we also have our user categories as either A or B. So applying our framework, we have our format portion of our framework. So as mentioned during the analytical lecture, we're going to be working with our data set in CSV file format encoded using UTF-8. So when we export our file at the end of this case, we will want to make sure that we are using the .to CSV function to deliver that as a CSV, that we're using the right file format or file type, and that we label our encoding appropriately. Now, in practice, do you always label your encoding? Not always. You'll see it often where it's just not labeled or the encoding is just whatever it is. You sort of take a risk there, and it is better practice to always explicitly state your encoding. Again, I see some really great advice in the chat. I'm definitely going to encourage y'all to keep sharing tips and tricks with each other. I believe the default is UTF-8 for encodings. I saw a question there about that, so I believe it is UTF-8, but again, it's just better to explicitly state it. So now we're going to look at our relevance section of our framework. And in our relevance section, we said that we need to replace each of our missing bike IDs with a not available string, that we want to interpolate our missing values in the user category column, and that we want to replace each of our end station IDs with a not available string. So I'm going to quickly just go through this answer briefly. And we will work through these answers fairly quickly as we move through the case, so that way y'all have the ability to explore them more in depth on your own. So to replace the missing values of bike ID and end station ID with not available, we can work through that column and use the .fillinA function to fill those values. Now, the .fillinA function works to fill in the NaN values that are understood by Python. And we can fill that value with whatever we put in here. So if we wanted to fill it with, say, a mean, we could put the mean of our column inside this function rather than putting the string not available, and we can fill it with that value. We could put a placeholder of another number, or say -9999, or some other thing in that fillinA function to be able to fill that column. And we do this for the bike ID and the end station ID. Okay, so now we're going to work on interpolating the user category. And we're going to use the .interpolate method in pandas. Now, the .interpolate method is a method of linear interpolation, which is basically a mathematical way of filling in unknown values based on building a simple linear regression on the non-missing points. So it takes the data that you do have, builds a linear regression model, and then uses that estimated linear regression model to fill in the values in your data set. So we can use this to use the assumptions of a linear regression to fill in our non-missing points. And this is a pretty straightforward way of interpolating. Yeah, y'all heard my dog in the background. Okay. Now, this method is very different than, say, substituting null values with a randomly generated value or a meaningless value, or even using the measure of centrality, such as the mean, median, or mode. But the using the linear regression model preserves the aspects of our data distribution, so it keeps the shape of our data the same as we estimate, okay? So we're not filling in things from the end, but we're rather using the shape of our data as it exists to flesh out or fill in those missing values. Okay. So our user category, though, is a string. So how can we apply a method to a string? Now, luckily, our user category only has 2 values. So with that, we can convert it to a category using the @.asType function, and then we can run the interpolation on it. And we'll dive into how this category data type is really useful here in a second. So first, what we're going to do is we're going to take our column, then we're going to set that equal to our column again, but being changed as a category data type. And here we just write in category for the as type. If it was a string or an object or some other data type, we would just fill in that data type here rather than having category. So now that we have this category, we can see what those actual categories look like and how they're being interpreted by pandas. So here we're pulling that column and we're using this .cat sort of notation here. The .cat brings into play the category group of functions that exists within pandas. Now you may have seen .str for string methods. Here we have category methods. And then we have .categories. Now here you can see that this is not a function. This is again an attribute of that column. So when we're calling this, it's giving us the information of the values of the category within that column. So here we're seeing that our categories are A in brackets and B in brackets. And those are our actual categories that Python is interpreting. But underneath that, we can actually call .cat.codes, and the category codes are the numerical representation of the data that exists underneath these categories. So when we use the category data type, we're actually communicating the label of the category, which is the human readable string version, but also an underlying numerical understanding of those values. And this is how we can use interpolate, is when we have this underlying numerical value with our categories, we can then predict numerical values. So here we have 0, 1, and -1. Now 0 is for category A, 1 is for category B, and the -1 is for missing data, because missing data still needs to be represented in this data set because we have missing values in this column still. So that is actually represented using the -1 value. We're using the .unique here, by the way, as a way to just show the unique values that exist within the data set. If we didn't have that, it would return every value with or every category code within the data set. Okay, cool. And here is a note within the case that the number -1 represents NaN values or missing data. Cool. So now we're actually going to use this interpolate method to deal with these actual missing values or the -1 values. Here is where we're actually going to use NP or NumPy to identify those NaN values. Now, because we're working with this one series, we can use NumPy to identify those NaNs because we're existing within this one series. So to do this, we are first taking our user category from our data frame. We're creating a list of those values, or we're creating a series of those values, I should say. And then we are getting the cat codes, but we are replacing our -1 with this NP-NaN value. Okay, so we are modifying the underlying data now to be 0, 1, and an NP-NaN, not a number value. And that NP.NaN is used as within our interpolate function, and that's how it gets recognized as a missing value. If we just use the -1 directly, interpolate wouldn't necessarily identify that as a missing value. So we have to officially declare that, so that way interpolate just fills that in for us. So then once we have that replaced, our values are 0, 1, and NaN. And then we use our interpolate function here to fill in all of the values within that series. And here we can see the output of that. So we get 0 and 1s as an output of our series. Now, question, why do you think that those values have decimal points? Yeah, so they are all float values because NP-NaN is a float value. So because we were using NaNs, all of our values have to be in a float format to be able to operate the way that we need them to. And we could even see that down here with the data type being listed. Okay, cool. So now that we have these values, we actually want to convert them back to our category, right? We want to make sure that they actually come back to a category. So because right now we just have a list of these values in their own series. These are detached from our data frame currently. We pulled them from our data frame up here, but they're still just sort of floating as their own data element. So we want to turn these into categories now, right? We want to change this type. So to do this, we actually do a couple of things in this function. First, we change them to an integer, and that brings them back to our 0 and 1 format that we had. And then we change them into a category. Now, through this case, there are different steps that we could take here. We could modify it. We don't have to follow this process exactly, but this process works for the way that we're playing with our data right now. So when you're dealing with this in the real world, these steps may be a little bit different, but will probably be similar. Okay, so once we have those changed back to categories, now we actually replace those 0s and 1s with our actual category names. And to do this, we're going to use the function rename categories out of our category group of functions. Okay, so to do this, we take the user cat codes that we have in a series, we rename those categories using the categories that we established in our data frame. So we are relating, we are relating this set of series, or the series of values, back to the categories that we originally had in our data frame. And then once we have that, we just assign that series into a column in our data frame. And that column will match up with the order that the data frame already existed in. So we end up filling it out. So now there are a bunch of questions about our interpolation and what we did sort of diving into that interpolation. So here we are just using a simple linear regression. So we are assuming that this interpolation method doesn't need to be that exact, and it's just an estimation of missing values. Now, when we were looking at our data set in the previous lecture, we saw that in the 1,000 rows or the 10,000 rows that we had here, we only had what, like 63 missing values. So it's a very, very small portion of values that are actually being modified by this. So it doesn't really modify our entire data structure at all. So we could spend a lot of time diving in to the values there, but we're just really using the interpolation assumptions to get those values. And for more information on interpolation, you can actually look up the documentation behind it. And here you can see that the default is a linear method, but there are a ton of other methods that you can use. All of these methods come from the SciPy interpolate methodology, and Pandas acts as a wrapper for those values. But there's more SciPy interpolation sort of approaches that you can use. And this really is a very expansive arena where it's really just up to you how much time and effort you want to spend on answering it. When we're performing the linear regression, you can think of it as using all of the other features to create one equation. So it's using all of the other values in the data set to predict, well, all of the numerical values to predict. Okay, there's a lot of questions in here. Alberto, is it a good idea to create a new column with a flag to indicate that a row is interpolated? I think that would be referenced in the data documentation that you write up about the process of preparing the data set. So yes, so Andres, is it interpolating between the previous and following values? It's not really filling it in like it would just like a line or a linear sort of approach. That is an approach to interpolation, lining up all the values and just filling them in based on where they occur on that numerical line. But the interpolate methodology here is actually building a linear regression, taking all of the values that are in the row and creating a prediction for the missing value. So it's a little bit more robust than just lining it up and filling it in. It's using it's actually using the data distribution to fill in the values. So it is an informed guess, essentially. Okay. Cool. Let's go back to our case and keep moving forward. Okay. So now that we have those category codes being delivered and we've reinstituted them, we can call this column and see that the values are now A, B, A, B, etc. We can also see that our data type is a category here, and we can see that our categories are two objects, A and B. So we can get some information there. Okay. Cool. So is there an issue with sound, y'all? Let me try and. Okay, is that better? Y'all have a ghost. Ah, I'm friends with ghosts. That's fine. maybe it's Casper the Family Ghost. Okay, I just turned on and off my mic, so hopefully that's better. But if it happens again, let me know. Again, keep an eye on the chat to make sure that y'all have the best experience possible. Okay. So now we're going to dive into consistency, and we're going to talk about our different data types our different data types here. So we examined the data set previously, and we saw that we wanted to change a bunch of our column data types into more appropriate data types. And we ran through this in our analytical lecture, so I'm not going to go through all of this, but essentially we want to change our IDs to a category. We want to change our start and end dates to date times, and we want to make sure that our tags and the user category column that we were just working with exist as categories. So the exercise here is to change the data type of a series in pandas using the asType function. And we're going to make all of the changes for all of our category columns, and we're going to leave the date times alone. So since we're not actually doing the exercises tonight, we'll just run through this. But essentially, we're just taking each column and using the asType function and category to define this. Now, you'll see something interesting here. We have double quotes here, whereas previously up above, we were using single quotes. That does not matter. So you can use single or double quotes there as long as you're consistent with it throughout your code. So that's not a big deal because it's consistent in this code cell. Cool. So after we do that, we've changed all of our category types to be category, but we haven't touched our date times yet. So in our data set, we have this date format of 12/08/2022 with a time here. And this follows a day, month, year format. And our time is in a 24-hour format. So this is a very common sort of date-time format that you'll probably encounter. We see that our date and our time is separated with a space. So to convert this kind of data into an actual date time column or a data type in which Pandas understands it as a date, we use the pd.toDateTime function. And this is a function within Pandas that automatically detects the date format and changes it to what we need. Now, 8 out of 10 times, this is going to work great for you, and it's going to be very reliable. Sometimes, though, it will not work correctly. So you do need to check this to make sure that it is converting the dates appropriately. If you end up getting random dates, I think the classic example is you end up getting dates that go back to 1970 something. That's a clear indicator that this did not modify the date correctly. And that is something that you will see in real life and in real practice. So, so just be careful of that when you're looking through it. But the toDateTime function is really robust. It identifies the date usually for you, and you just pass the column to it and rewrite it like you would when you're modifying data in a data set. Cool. So in exercise 2, we are now going to create a new column, and we're going to create our duration minute column, which is the one that we were sort of working with or said that we needed in our analytical case. And this is going to give us the duration in minutes instead of seconds. So to do this, there's actually 2 options. The first is to create our duration column and just do a simple subtraction of our end date from our start date. Now, because we changed those columns into a date time data type, when we do this, it's actually going to return what's called a time delta value. And this is the change in time. Delta is a mathematical symbol that's often used to represent change. So when we say time delta, it's the change in time. And that is sort of just whenever we do arithmetic in Pandas with date time, we'll get time delta formats back. The other approach is to just take duration as it currently exists in seconds and just subtract 60, or sorry, divide by 60. And this will give us the number of minutes that exist for that seconds duration. So both of these options will work. The note, though, is that the first option brings back a time delta column. rather than a value column, or like a value column of like an integer or a float. Okay. Cool. And then once we have our duration minute column, what we're going to do is actually drop our duration column. And this is, again, going back to relevance to make sure that we are only containing our relevant data. And yeah. So we are going to work and drop that column. And to do that, we just use df.drop. Now, df.drop is a pretty aggressive function, so you kind of want to be careful when you're using it. But when you want to remove a column, drop is sort of the standardized way to do that. Okay, there's a lot of questions, so let me look at these for a second. There's a lot of specific questions about date time. I recommend doing a Google search for those. Go to the pandas documentation about date time, or to date time as a function, and you'll find a lot of in-depth data there. Should we first check if duration has NaN values? We're doing these operations sort of regardless of those, but we did also look at our data in the analytical case when we got that report. Okay. Cool. Awesome. All right. So now we're going to work on fixing up our tag column and making sure that we have categorical consistency in our data set. So to do this, we want to only have 3 categories of low, medium, and high, but according to our report, we have 5, and we identify those as the capital P priority, the priority underscore high, the priority underscore medium, and we identified these sort of odd values for our categories. So we want to go through and we want to standardize these. And the way that we're going to do that is we are going to create a dictionary where we set up the key value pairs. So if we have priority low in our data set, we want it to be just low, all lowercase. So this is the dictionary where we are assigning those associations. Then we're going to take our df tag column and we're going to use the dot replace function. And this is a function that goes through the column and replaces one value for another. Here we're loading in the dictionary that we just created because it shows those associations between the key and the value. But we could also just put in one value in that replace function and put the value that we're changing, comma, the value that it should be as well. And then we are going to end this function here by changing the type of the data to a category. So again, maintaining that consistency in our data set. So we run this and we get a series back here because we're calling this one column. So we get the series of mediums, lows, highs. We can see that the data type is a category. And we can see that the 3 objects within our category are high, low, and medium. Okay, so now we would do a replacement for the user category column. Since we have some weird formatting here of bracket A, bracket, and bracket B, bracket, which essentially represents the A or a string being inside of a list. So it's the sort of nested data in a sense. We want to switch that out though, and just make it a simple string of A and B. Now, actually, I say string there, but to be more correct, it's actually the category. We want it to be the correct category of A and B. So to do this, we're going to set up our dictionary and do a simple replace here. This is kind of separated out a little bit weird, but we're creating our dictionary. And we can use .rename categories to rename our values, which is a function within category. Or we can keep what we just did and use the .replace and as type category. Now, this is showing that there are two different ways to achieve the same thing. So both of these codes are correct. They're just different approaches, and whatever you want to use, you can use here. Okay, so now we're going to work and drop our duplicates in the data set. We're going to do this to just make sure that we have referential integrity in our data frame. So to drop duplicates, we're going to use the .drop duplicates function. This is a pretty aggressive function, but when you run it on an entire data frame like this, it's truly looking for entire duplicates across the entire row, which should be a very rare occurrence. You should not have duplicates across the entire row. That usually is an indication that it's a true duplicate. So you can drop duplicates using this method. If you applied this though on one column or just a subset of columns, which you can do, you have to make sure that the repeating values are true duplicates and not just repeating values within the data. That's one quick way to delete a lot of data that may be very important. So you really want to think through how you're using drop duplicates and make sure it's being used appropriately for what we're trying to achieve. Cool. So we can run that. It drops duplicates. We use this assignment function, so it is still our data frame. Okay. So now that we've gone through this, we also want to create our trip IDs. We mentioned this in our analysis. So when we're generating unique identifiers for data sets, we want to make sure that the generation process of IDs is idempotent, or basically that the same ID gets generated for the same trip, no matter how many times we run our script. So things aren't being willy-nilly replaced, but IDs are being assigned sort of more in a methodical manner. Cool. So this is a sort of required thing because the chances that the same trip are inputted into a tool multiple times, for example, may add duplicates in your data, and you want to make sure that those IDs stay consistent throughout and aren't just being reduplicated. So say a customer first uploads a data set for the first week of the month, and then later uploads the data set for the entire month. That entire first week there needs to be a way to prevent that from being duplicated. So we want to make sure that those IDs stay consistent. So one approach to doing this is creating an ID based on other columns in the data set and sort of joining them together to create a trip ID. So one way to do this is using the start date, the end date, and the bike ID. Now, once we do that, we really just have a string that's joined together. It's pretty understandable human-wise, but it also means that it may be fallible. So a little trick that we can do is taking that trip ID that we create with those different elements and then doing the base 64 encode and unencode, or an encode and decode sort of step. And this is a little sort of hack to encode it into its base values and then re-encode it back into machine language. And by doing this, it gives us values like this that are sort of very long, very unique, and not really duplicatable. But it does it in a way that's sort of systematic, following the encoding and decoding process to make sure that these values, no matter what when they're uploaded, it's the same value. Okay. So this is just, don't get hyped on this too much. This is just one presentation of a way to use encoding and decoding features within Python and within Pandas to build out truly unique identifications. Okay, so don't stress too much over this. Okay, so now that we have that all done, we've done a bunch of stuff so far. Now we are going to work on renaming our columns so that they are all in a clean and presentable format. To do this, we're going to make sure that they're all lowercase and that we separate words with underscores. So to do this, we can set up a dictionary of the columns that exist and the column names that we want it to be. And we do this for each of the columns in our data set. And then we can use df.rename and use that columns dictionary to reassign those columns. And then once we do that, we can call df columns to get a view of the columns that exist. So here we have rental ID, bike ID, and date, et cetera, et cetera. So is there a function like row number in SQL for Python for generating DIDs? So there is a function, there's an index function in Pandas. And if we look at, our data set here, we can see that we have these values for each element in our data structure, whatever it is, whether it's a series or a data frame. And that's an index, so that's a value indicating the row. But in Python and in Pandas, indexes are not static, whereas in SQL, you can assign the row number to be a static element that never changes. In Pandas and Python, you can manipulate row indexes. It's viewed as sort of, it's sort of viewed as another column, but with additional features that you can use. In Pandas, each row has a value, and that's the row index. And then each column, the column names that we've been using are the column indexes. So, that's the most similar. But in SQL, that row number is structured to be non-repeating and specific and not changing across that data structure. You can also set values as an ID in SQL, and that ID is set to not repeat. It's a unique identifier. Oh my God, I see all the ghosts again. Okay, I'm sorry. Zoom can't handle our data science knowledge. It's okay. All right. So now we're going to dive into data augmentation. So our priorities here are to merge our data sets, and then we're going to create a bunch of following features. We're going to create the day of the week. We're going to create the hours. We're going to get our total costs of rentals, and we're even going to dive into generating more information about the location of our station. So to merge our data sets, we first need to read in our stations.json data set. So here we're going to use read underscore JSON to bring in our JSON data file. And here we have this orient equals columns. Now, there are two ways to bring in, there are two main ways that JSON files are structured. And one of those is columns. And in the orientation of columns, the JSON is structured as a dictionary, the first column, and then each of the rows within that column. And then it goes into the second column and then the rows within that second column. So this orientation of columns prioritizes columns first and then rows. But we may have JSON in more of a situation where we have rows and then each column. So this is row 1, and then this is column 1, column 2, so on and so forth. And to read this format, we would use the orientation index. Again, in pandas, indexes are rows, or the row, the index value is rows, whereas we have column indexes for columns. So we can use this read JSON function, and we can tell it how our data is oriented. So when we read it reads it in appropriately. Now, fair warning with reading JSON into Python, or reading JSON into pandas, I should say. If you're dealing with very deep hierarchical JSON data, this may be a more complicated process of bringing in JSON data and flattening it. But often this read JSON command will be all you need to get the data loaded into a pandas data frame. So here we can see that if we have J with row 1 and column 1, if we orient it as an index, we get column 1, or column 1, column 2, and then we get our row 1, and then the value in there. So that's what returns if we change this to columns. It will change its value, and we see that it's now switched. Okay, so that's a little bit of detail on that orient feature of read JSON. And yeah, hopefully that helps understand that a little bit. Okay, so we read in our data and we have our station names here. And we can see that our station names have this first value, a comma, a second value. We've got our latitude and longitudes and our station IDs. So we want to create a location column here before doing our merge. And we want to do this just because it's a little bit easier. So to create our location column, we're going to end up using the .str, which stands for string. So this is string methods within pandas. And we're going to use the .split function. And the .split function takes our strings and splits them based on an instance of a particular value. So here we have commas separating our values. So we can use .str split to split our data to break it out into this list. And this is sort of the standard thing that gets returned. We get this list where each of the values within that list correspond to the position of where they were before we split the string based on the comma. And here we are splitting the string based on this pattern equals our comma, but we could change this. We could put whatever we want there or whatever we need there for that split. So we can return that as a list. And each element is split between the commas, so that's cool. And we can access these elements as if they were a list too, right? So if we want to get into the 0th, the first or the second position, we can get those values. If we wanted to return a data frame instead of a list here for these values, we can do that using the dot string split method, but adding in the argument expand equals true. And that will return a data frame of our values, where now we have the 0th element, the first element, and the second element broken out into columns. So now we're going to apply this dot string split method to our stations in our JSON file. So we have stations and we're getting the station name, and we're splitting that using a comma as our pattern. And we're also going to expand this as true. So based on what we just talked about, it's going to return a data frame. And then we use the dot head function to return that to C. So here this is what we get. We get 0, 1, 2 as our columns, and we get our values there. Now question, why are we getting none values in this second column? Yeah, okay. So many people, so many ideas. This is awesome. A bunch of people sort of said it, but yeah, there are locations with 2 commas. So we end up getting 3 values returned instead of 2. So if we look at our data that we're looking up here, we can see that most of these are probably only like 1 comma separating these values, but there may be another comma here with a 3rd element. And we could actually look into that a little bit. So to dive into that, we can get our split columns and we can go into our second column here. So split columns are second column. And what we're going to use is dot value counts. And this is going to return a count of all of the values and their appearances within that column. So here we can see that we have Wandsworth Road and Stockwell, and those are the only 2 values that are returned in that column, and they only get returned once. So we only have 2 instances of an exception to the pattern of a first element and a second element. So luckily for us, our string.split methodology actually has an argument of n equals that we can include, and this indicates the number of splits that we want to occur. So when we pass my string.string.split with this n1 argument, we're saying split only at the first comma. And that will give us a result of 1 element and a second element, and that will be the entirety of the split. If we change that to n equals 2, we would get the 3 columns that we already see. Now, sometimes you may have data values with a lot of separators, and you may want to separate in different places. But you can use this as sort of a way to get what you need or get what you want in the way that you need it. So we use our split columns. We call our stations and the station name column within our stations data set. Then we use the dot string split methodology. We say, hey, our pattern is a comma. We only want 1 split, and we want our results to come back in a data frame. And that's what that tells us in this code. So then we get that, and now we see that it is returned as 2 columns, not 3. Cool. So now we've gone through that, and we've sort of gotten a feel of our locations. So now we're going to add these columns to our stations and do some corresponding adjustments. So we've split these. Now we want to add these back to our original stations data frame, right? So we call stations, we do pd.concat And this is going to concatenate our columns together. And we're taking our stations, the split columns data frame that we have here, and we're saying bring those together and use axis 1, which is our columns, to bring them together. And that's how we're going to concatenate them together. Now, we could do other things here. We could have done, actually, let me ask you, why are we not doing a merge or join here? Yes, y'all hit it. Awesome. There is no key value pair between these, right? We took the split columns and broke them up and we just rely on that positionality. But if we went to match this, the values wouldn't match because, I don't even have it up here. Okay, there we go. Because the values here are together, they're not split. So we can't have that one-to-one match to do a join. So we are just concatenating it by attaching it. We're just attaching it to the side. So that's a great thing to highlight there, is that there is no key there to bring them together. Cool. So then we're using a rename dictionary here just to rename our columns. We've done this before. And we're using the dot rename function here, saying, hey, our columns are in this rename dictionary. So we're renaming our columns, and then we're dropping our station name column. And this is because we have the station name from our original data set with this capital, but we have the new station name that we just added in lowercase. So we're dropping the original station name where everything is together, and we're just keeping the 2 columns. Again, this is to make sure that we are reducing that data redundancy. And then once we have that, we are turning that back into a category. And we're doing this because the stations are different. So they're different like units and entities, and we're viewing them as categories for this. And then we're returning the head of the data frame. So now here we see we've got our station IDs, got our latitude and longitudes, and then we've got our station names and our locations. So we've cleaned up our stations data to make it better suited for our needs. And to just finalize this and make sure it's super, super clean, we're gonna use the .string.strip function. And this is gonna remove white space. It's going to remove trailing and leading white space. And that's where, like, if you press the space bar, that's a white space. It's just a blank space. And often when we're dealing with strings, sometimes they can exist at the beginning or after, especially after we do a split. Like if it was comma, space, and then the value, that space would stay. So we need to remove those trailing and leading white spaces. And .strip is a great way to do that. If you wanted to remove trailing spaces, you can do lstrip, and that would remove the white space on the left-hand side. Or you can do rstrip to remove the white space on the right-hand side. But strip as just .strip will remove from both sides. And here we can see an example. If the string is space hello world space, we can strip that to just be hello world without those spaces. Okay, you can also strip things with other values or other special characters. So say you had underscores in your values, you can do .strip and pass the value of that underscore to the toStrip argument within the strip function. How many times can you say strip in one night before the word starts to sound weird? But yeah, you can pass a different character there to help strip and clean up whatever values you're working with. Okay, So once we've done all of this cleaning of our stations data frame, we now want to bring it back and tie it back into our data frame. So to do this, we're going to do a pd.merge. We're going to take our right-hand data frame, our left-hand data frame, and we are going to merge them together. So the left on is the start station ID, and that's what exists in our data frame. And then the right on is the station ID, which exists in our stations. And we're going to merge using a left merge. So we are going to keep all of the values in our data frame, and we're going to attach the matching values using the stations data frame. Okay, now if we wanted to do a different type of merge here, we could. Lefts are really, really useful because it preserves all of the data on our left-hand side. Then we're using a rename dictionary, renaming columns. We're dropping our station ID again because we have it here from our data frame and our stations, and we don't need two of them, right? We're making one complete data frame, one complete data set. Yeah, so we're renaming and we're dropping a column. Then here we're doing a little bit of an interesting thing. We're taking our columns where our data types are objects, and we're creating a data structure of all of those column names within the objects. And then we're calling our columns that are of an object data type and just filling in the NA values with not available. So we're taking all of our other string data or object data, and we're just calling all of those columns at once to fill the NA using the not available. Now, other ways that we could have done this is we could have called all of our data types and just listed our columns in a list here rather than using this object column sort of thing. But this is a different way to see it, and this operationalizes it a little bit differently. So it's good to see a different example. Okay, and then once we get that, we bring the head of our data set, and we can see that we have this data set here. So we have got our rental IDs, our bike IDs, we've got our end dates, our start dates, the station IDs here, our tag, we have our user category values, we have the duration in minutes, and we have our trip IDs that we built in, and all of the information from that data frame that we just brought in and merged as our stations data frame. So we have all of that together. So there's a modification here where you're going to copy this code essentially, and you're going to merge it for the end stations. So we did that for the start stations, and now we're going to do that for the end stations. I'm going to sort of skip over this code though, because it's an answer, and we'll just get down here. So now that we've done that, we have our start stations and our end stations. The code though is pretty much exactly the same as what we did, just using the end station IDs instead of the start station IDs. And the reason why we're doing that is because in our original data frame, we have two representations of our stations, right? We have the start stations and the end stations, where our journey started, where they end. Our stations data set that we were building on working has all the information for all of the stations. We need to associate that station information with those trips. So we're doing it first for our start stations to get all that information from the start of the trip. And then we're going to do it for our end stations to get all that information for the end of the trip. So we ultimately have a data frame of all of the contextual information for our trips. Okay. And then we are going to now look at building out some last couple of features that we want to include. So we're going to get our start weekday, our start hour, and our rental cost. So first we're going to start with our start weekday and our start hour. So in order to do this, we're going to bring in a data frame here using our exercise data frame. And when we're bringing in the read CSV, we can actually tell read CSV, hey, there are date time columns in this, automatically change that to a date type for us. And that's where we have this parse dates. Now, I don't recommend doing that often because often the format that you get data in will not be set up the way that you need it to work appropriately. And if you bring this in on that initial read, you can't then go back and look at the CSV. You would have to reload it from scratch, and it's just easier to bring it in its natural state and to do the changes as independent steps. It's also a cleaner and more understandable way to view it when you're working with other people and they're working on your code. So to get our hour and our weekday, we use .dt.hour, and this is not a function. This is actually a feature, an attribute of this data. So because this is understood as time data, that time data has a whole bunch of information that pandas can automatically interpret. And getting the hour and the weekday are sort of benefits of that data type. So we can get our hour by just calling dt.hour, and we can get our weekday by just calling .weekday. There are a ton of other features or attributes that we could get. We could get the time zone, we could get the year, the month, the day, the minute, the second. It goes on. I think it goes down to like nanoseconds, milliseconds. It gets pretty deep. Granted, though, your original data has to have the information to get that stuff, but you can dive pretty deep into it. Okay, I think we're going to actually keep this exercise for y'all to do tomorrow regarding the rental cost. Yeah, okay. I'm actually going to skip over this so y'all have time to do this tomorrow, but we'll go through it really, really quickly. So the rental cost that we have here, we know that our rental cost is £2 for the first 30 minutes and £2 for each additional 30 minutes. So what we're ultimately going to do is create a data frame where we have our rental ID and a value of how many rental costs are associated with it, or the rental cost associated with it. We're going to use the dot ceiling function from our math module to get this information and to round up. So this dot ceiling function comes from that math module that I mentioned at the very beginning of this lecture. Here is one approach using a lambda function to get the ceiling from our duration minutes. Once we have that value here, we have our time blocks, which gives us the number of blocks of 30 minutes. And then we're going to subtract 1 from that. This is just how this process works. Then it's going to get grouped by the rental ID, and the time blocks are going to be summed. And then that rental cost value is going to be multiplied by the £2 value. We ultimately drop the time blocks and we get the rental cost in our data frame. Now you're going to be working on that tomorrow, I believe. So I don't want to dive too much into that, into the actual code. Finally, once you have that rental cost data, which we have here in the CSV that we can read in, we do a simple merge to merge that to our data frame. Again, left on our rental ID, right on our rental ID. And it's a left join to keep it consistent and to keep our data frame intact. And then here we're setting the index to our trip ID. And when we do that, we now set that index value or the row value to the ID that we had associated with our trip. And this may actually look a little familiar to those who have practiced with SQL. And then finally, we use that export. We export our CSV using that toCSV function that we mentioned at the very, very beginning. And we establish our encoding as UTF-8. And that is the lecture. I know I ran a couple minutes over, but I think there's a lot of information here. So hopefully this was really, really helpful for you. And if you have any questions or anything, I am free to stick around for a few minutes. I'm going to pass it over to the powers that be, though. Monica Diaspora Colombia, which I believe is Oscar. If y'all are here, yeah, that's a wrap.
That was awesome, Jonathan. Thank you very, very much. I'm pretty sure all the fellows loved this lecture. So,
It's
guys,
awesome.
thank
So
you.
great to hear.
Thank you also for being here. And well, this is all for tonight. Thank you again, Jonathan. Hope to see you again soon. And guys, see you also tomorrow for the, more data science.